us look at an example. We have already established the sample space of the experiment of rolling a dice twice. We know that the sample space has 36 outcomes, and these are the 36 outcomes that are listed in the sample space. Each one of them are equally likely. That is another assumption we have, and we also know it is a good assumption, it is not a bad assumption to have. So, now let us define 3 events. E1 is the event that the first outcome is a 3. So, we can see that this outcome, this outcome, this outcome, this outcome, this outcome and this outcome, namely 3 1, 3 2, 3 3, 3 4, 3 5 and 3 6 are the outcomes in my event E1. E2 is the outcome, sum of outcomes is a 8. So, now I can see that, let me denote it by cross 5 plus 3, 4 plus 4, 3 plus 5, 2 plus 6 and 6 plus 2. These are the outcomes that satisfy this, and they are in this event E2. Now, when I look at sum of outcomes as a 7, I see the outcomes, I put a circle here 1 0, 2 5, 3 4, 4 3, 5 2 and 6 1. These are the outcomes in my event E3. But now that is, having defined these events, the question we are asking is, are E1 and E2 independent, and are E1 and E3 independent? So, before we go to verify whether E1 and E2 and E1 and E3 are independent events, let us look at the intuition behind independence. Now, E2 is an event where the sum of outcomes is 8. Now, let us write down the following: the first throw of a dice and the second throw of a dice. Now, to get the sum of 8, okay, if the first throw was a 1, I cannot get a sum of 8 because the maximum that I can get in a second throw is 6, and 1 plus 6 is 8. So, if the first throw is a 1, I cannot get a sum of 8. The first throw is a 2, I need a sum of, I need to have a 6, 3, 5, 4, 4, 5, 3 and 6, 2. In a sense, to get a sum of 8, I need the first row to be either 2, 3, 4, 5 or 6 to get a sum of 8. Now, let us repeat the experiment with 7. So, if I have sum 7 written here, the first row is a 1, then if I second row is a 6, I get a sum of 7, 5 I get a sum of 7, 3 plus 4 is a 7, 4 plus 3 is a 7, 5 plus 2 is a 7 and 6 plus 1 is a 7. So, to get a sum of 7, I see that the first row can be any of these 6 values, and I get a sum of 7 which is possible with the second throw. Whereas, to get a sum of 8, we saw that if the first throw was a 1, it is impossible to get a sum of 8. In other words, to get a sum of 8, the sum 8 is dependent on what was your first throw, whereas the sum 7 was independent of what was your first throw. So, this is the intuition. So, to get an 8, I could not have got a sum of 8 if my first throw was a 1, whereas a sum 7 is independent. Even if it was a 1 and I throw a 6, I get a sum of 7. If it was a 2 and I throw a 5, so it is independent of whatever was my first throw. There is a chance of me getting a sum of 7, whereas to get a sum of 8, I needed the first row to be either a 2 or a 3 or a 4 or a 5 or a 6. So, intuitively we can say that E1 and E2 are not independent, whereas E1 and E3 are independent events. Now, let us apply the formula to actually verify it. Recall, the formula states that If E1 and E2 are independent, then the probability of the intersection has to be the product of the probability. So, this is what we have to check. So, let us go to the first thing. E1 and E2 are independent. So, I know that E1 intersection E2 is the event that the first outcome is a 3 and the sum of outcomes is a 8. That is how I can articulate the event E1 intersection E2. I know that is only this outcome, and since all the outcomes are equally likely, I know the probability of this outcome alone is equal to 1 by 36, and I know that is what I have as the probability of E1 intersection E2, which is 1 by 36. Now, probability of E1. E1 is the event that the first outcome is a 3. Again, we saw that the first outcome is a 3 has these 6 outcomes where the outcome is a 3. So, my E1 event has the outcomes. The outcomes of the E1 event is going to be 3 1, 3 2, 3 3, 3 4, 3 5 and 3 6. Again, using that all of them are equally likely and the probability of events, I get probability of E1 is 6 by 36. Probability of E2, where the sum of outcomes is a 8, we also saw that there are 5 outcomes which give an outcome of 8. Hence, probability of E2 equal to 5 by 36. Now, you can see that 1 by 36 is not equal to 6 by 36 into 5 by 36. Hence, again using the if and only if condition, we can conclude that probability of E1 intersection E2 is not equal to the product of probabilities. Hence, E1 and E2 are not independent events. So, the next question we are asking is, are E1 and E3 independent? So, E1 intersection E3 is the event that the first outcome is a 3 and sum of outcomes is a 4. So, this is probability of 3, 4, which is 1 by 36. So, I have probability of E1 intersection E3 is probability of 3, 4, which is 1 by 36. So, I have probability of E1 as before, which is equal to 6 by 36. I can see that this is equal to 1 by 6. I have probability of E3. Probability of E3 is probability of 1 6, 2 5, 3 4, 4 3, 5 2 and 6 1, which is equal to 6 by 36, which is also equal to 1 by 6. Hence, I have probability of E1 intersection E3, which is equal to probability of E1 into probability of E3 in this case, which tells me that probability of, hence E1 intersection E3 is probability of E1 into probability of E3. Hence, the events E1 and E3 are independent events. Now, let us go and apply this notion of independence to our cards or deck of cards example. So, again consider the experiment of randomly selecting one card from this deck of 52 playing cards. Let me define the following events. E1 is a face card is selected. What is a face card? So, I have a face card is a card which has a face on it. So, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these cards which are referred to as face cards. These cards which has a face, namely Jack, Queen or King, are the cards that are referred to as a face card. So, a face card is selected. You can see that I have 12 cards, which gives me probability of E1 is 12 over 52. Now, probability of E2 is the event that a king is selected. Again, you can see that the event a king is selected is I have 4 kings, and the chance of choosing a king from 52 cards is going to be 4 over 52. A heart. So, you can see an event, a heart is selected. I have here 13 hearts. So, the probability or the chance that I am selecting a heart, probability of E3 is 13 over 52. So, these are the actual probabilities which I can have. Now, the question that is being asked is, are E1 and E2 independent events? So, now let us understand what is E1 intersection E2. Now, E1 is a face card, E2 is a king card. So, E1 intersection E2 is the event that a king face card is selected, which is equivalent to the probability a king is selected. Similarly, E2 and E3, what is the event E2 intersection E3? E2 is a king, E3 is a heart. So, E2 intersection E3 is the event a king and heart, in other words a king of hearts is selected. Okay. So, now the question we are asking, first question is, are E1 and E2 independent events? So, now let us look at the first question which is asking about E1 intersection E2, that is, knowing that a face card is selected, will that affect my chance of having a king? So, you can see that there are 12 face cards. Now, if I know that a face card is selected, then I know that the chance of getting a king from these 12 cards is 4 by 12, intuitive explanation. Okay. But whereas, if I know that a king is selected, the chance of you having a heart is just 1 by 4. Now, the chance of you having a heart from these 52 cards is also 13 by 52, which is 1 by 4. Now, this, whether you choose a king or a queen, again the chance of you getting a heart if you had selected a queen is also 1 by 4. Whether you had selected a jack is also 1 by 4. 10 also the chance of getting a heart is 1 by 4. 9 1 by 4. So, you see that the chance of you getting a heart is not dependent on whatever has been the card, whereas the chance of you getting a king changes if you know the information that what you had taken was a face card. Is that clear? So, now let us move forward and verify this. So, E1 intersection E2 is the event that a face card and a king is selected. So, we know that this probability is nothing but the probability of having a king. We know there are 4 king cards, which is king of hearts, king of clubs, king of spades and king of diamonds. Hence, the probability of a face card and a king is the same as the probability of a king, which is 4 by 52. So, what is the probability of a face card? Again, I know there are 12 face cards: jack hearts, jack clubs, jack spades, jack diamonds, king hearts, king clubs, king spades, king diamonds, queen hearts, queen clubs, queen spades and queen diamonds. Hence, the probability of this event E1 that is getting a face card is 12 by 52. Probability of getting a king is 4 by 52. You can verify 4 by 52 is not equal to 12 by 52 into 4 by 52. Hence, my probability of E1 intersection E2 is not equal to probability of E1 into E2. So, E1 and E2 are not independent of each other, something which we could explain intuitively. Now, let us look at the case of E2 and E3. Now, what is event E2? E2 is the event that there is a king, E3 is the event of a heart. So, E2 intersection E3 is the event of a king and a heart. In other words, you are selecting a king of hearts card. So, probability of E1 intersection E2 is just the probability of choosing the king of hearts card, which is 1 over 52, considering all of them are equally likely events. Now, probability of choosing a heart, so E2 probability of choosing a king is 4 by 52, probability of choosing a heart is I can have an A, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king or queen. So, 13 possible choices, it is 13 by 52. We observe 1 by 52 is 4 by 52 into 13 by 52. Okay. So, this is 13. So, I get this is 1 by 52. Hence, I can say that since probability of E2 intersection E3 is probability of E2 into probability of E3, E2 and E3 are indeed independent events. This is something which we even checked intuitively.